So next we have Kevin DELA ROSA here to talk to us, and my brain just shut off, which is kind of convenient. I actually brought Horse.js out here because he has the word intelligence in his title.
Okay.
And, you know, Horse.js just breeds intelligence. So take it away, Kevin.
All right. Thank you. All right. So, there's a lot of data out there. And in recent years, we've seen an explosion of like machine learning applications deployed in production, which leverages this data to do a lot of powerful things. So, for example, there are algorithms out there to help you personalize your musical experience. People have tried to learn to find faces in pictures, predict age or gender, and these type of algorithms have even been used to help manage the temperature of your thermostat. So in this talk, I'm going to give like a brief introduction to machine learning and motivated by a few different examples along the way and how you can do it in JavaScript. So what exactly is machine learning? So machine learning is a subfield of AI that focuses on algorithms that learn from experience. And they take these example experiences to make predictions on data. So for example, these algorithms can be used to adapt to your users to provide a more personalized experience. They can recognize patterns and replace humans in monotonous tasks. And they can also be used to separate the signal from noise in large data sets that you might not see otherwise. Generally speaking, machine learning applications fall under a few different buckets. So there are classification algorithms, which are used to categorize what type of thing something is. So for example, spam filtering or nudity detection broadly fall under this umbrella. There's also regression problems where you're trying to focus on the task of predicting some continuous number. So for example, you might be interested in finding the stock price of something or to predict the age of someone or how much money this movie might gross. And then there's problems that fall under the clustering side of things, which is a task that looks to cluster or group different items in an unsupervised manner. So think of things like image segmentation, where you might be interested in finding which pixels correspond to the border in some image, or some of the recommendation algorithms use this kind of abstraction. And there are many other types of algorithms out there, and new ones come up every day. But typically, when you're talking about machine learning in production, you have some pipeline that kind of looks like this. You have a step where you collect data and sanitize it. You make hypotheses and formulate some machine learning task, where you define what kind of features are relevant to your specific application. Then you train this algorithm by throwing different examples that you have at it to tune the different parameters in your learner. Then you do some evaluations of your different models to see what worked out best. And when you're satisfied, you deploy it and apply it to new data that you see in the real world. So I'll walk through a specific example and show how each of these steps kind of apply to it in machine learning. Specifically, we'll talk through how can you determine the polarity or sentiment in a tweet, right? So first off, why would you care? Why would you do this? Well, if you're a brand ambassador or somebody in social media, you might want to know how do people perceive a topic or a conversation. And doing these kind of analysis can help you get some insight on how people are talking about your product, or who's talking about your product in positive or negative ways. So first off, we need data, right? So there are many data sets out there that can be used off the shelf, and I've listed some here, Sanford Tournament's Twitter sentiment data set, and a few other different data sets targeted at specific topics. If you don't have a data set that's relevant to you, you might want to scrape Twitter or query their APIs to find more relevant tweets to your problem. But then there's a caveat of, well, these things don't have labels, right? So we kind of need to have some examples so that our algorithm can learn. So if you don't have labeled examples, one thing you might do is kick it off to some crowdsourcing platform, like Mechanical Turk. So Mechanical Turk is a crowdsourcing platform in Amazon that has different templates and different hooks for you to like throw out microtasks, like judge this tweet for sentiment, and give me back the results so that I can use it to train an algorithm or something. So for this example, we'll just use something off the shelf. We'll use the Stanford Twitter dataset. So in this dataset, they have about 1.6 million tweets collected by querying APIs with different keywords. And they did something unique with this dataset. Like they inferred what they thought the sentiment was based on like the presence of different like emoticons. So like a lot of smiley faces, like they thought that is an indicator of positive tweets. Frowny faces is an indicator of negative tweets. And anecdotally, this actually works surprisingly well for their task. So yeah, this is like a huge CSV with 6 columns, some label for your polarity, either positive, negative, or neutral, some metadata like the ID of the tweet, the date they queried it, and the user, and also the actual tweet text itself with these emoticons stripped out so you don't just learn against checking the presence of emoticon. So, now that we have data, let's move on to like how we would actually use it. So like this problem largely falls under the classification family of algorithms. So you want to predict polarity, meaning you want to predict a class of negative sentiment or positive sentiment. And in our data set, we have like some metadata and tweets, but like how do we feed this into an algorithm? So we need to define some sort of feature set. So features are how you represent your examples as input into a machine learning algorithm. Like at a high level, these are usually like arrays or dictionaries that you pass into an algorithm along with something that it's trying to learn. In natural language processing, you'll typically see a lot of tasks be accomplished with simple features like bag of words, meaning taking a sentence or document, tokenizing it, and then using the resultant word tokens as features into an algorithm. So if you want to do a task like that, there are a few different libraries that can accomplish it. So there's an NPM package called Natural that can actually provide a few different word tokenizers. This one here is a pretty simple word tokenizer. All it does is split up your input text based on white space and like different punctuation. And when you provided a sentence, it'll spit it out as an array of strings. In this case, it turns it into 9 tokens. All right, that's nice, but like tweets are a little different than classic text, right? Like they're short, they're full of jargon, they have a lot of abbreviation and informal language, and like the punctuation is oftentimes used to like encode important things. So using like a standard tokenizer probably isn't what you want to do for this task. But based on domain knowledge, we'll kind of model our features that we'll feed into the algorithm on the bag of words model, but with a few different normalization applied to the different tokens. So first off, we'll create a few equivalence classes. So we don't care about all the users, we just care that there is a username in this tweet. Likewise, we probably don't care about what URL is in here. And in Twitter or social media, there's a lot of like use of excessive letters, like you might say no with like 50 different O's. Here, we'll map the 50 O's and the 3 O's to the same kind of token. And as I mentioned, like normal tokenization typically doesn't work well on Twitter, so we'll use a special library called Tokenize. Tokenize works very similar to the Natural's word tokenizer. You feed it in a sentence or a tweet, and it'll return different tokens. As you can see, it maintains a lot of punctuation in it, and it keeps the URL intact, and like there's a little music symbol, for example. So this is very helpful for tweets. So putting it all together, we take in. Here's a random tweet that I found about Comic-Con. I ran it through like these few steps, and we get out a feature array here, which is the normalized lowercase version of this tweet, with some of the terms being replaced with the equivalence classes, like query term and URL, and the long yes, like compressed to a smaller yes. So, okay, so now that we have like a high-level idea of how we're going to represent these examples, let's go throw it at an algorithm, right? But which one do I choose? Like, there's like hundreds of algorithms out there. It's like, and I'm just list some of the more popular ones up here, like k-nearest neighbors or support vector machines, etc. The rule of thumb here is like, I tend to use things that are simple and things that I am familiar with first, and then branch out to more complicated and other things, after they haven't, weren't performant enough. So yeah, just start with your favorite classifier learner. So we'll use two of my favorites. There's an NPM package called Brain, which provides an implementation of neural networks. In this example, we have the creation of this net variable, which is your brain object. Then you train it by providing different inputs and corresponding outputs, and it tries to learn, at the bottom you see the run method on an example, and it's trying to learn what value should I output. So in this example, let me add some color to it. We're trying to learn, given some RGB color as a background, what text color would people most likely want in the foreground. And this is kind of based on different votes people gave, and so for example, someone voted for this green to put black text on it. For the black background, someone voted white, and the purple, someone voted white as well. And as you feed more examples into it, you can better train your algorithm to be more accurate. But throwing in orange here will actually output white as the most likely thing that people would want as a foreground color, and black as the less likely output. All right. Another simple classifier is Naïve Bayes, which you could look up the implementation details on Wikipedia. It's a pretty simple algorithm. Natural provides a natural language focused implementation of this classifier. So what we're doing here is we're throwing different sentences and trying to determine, are we interested in buying something or selling something based on this sentence? So we have four examples here, I am long Q and short gold, sell gold, things like that. Like I mentioned, you collect this data, you train it by calling train, and then when you're ready to do actual inferences, you could call the classify method to make predictions on unseen data. So when you call it with I am short silver, it'll say sell, right? And under the hood, this does a lot of featureization for you. It does word tokenization, removes stop words, things that are uninformative, like the word the or of. And if you're ready, do your kind of normalization and featureization, you can feed that in as well as an argument instead of text. So like for us, we're more interested in passing in features that we already set up. So you can pass in an array, and that will work as well, and it won't do the additional normalization. Another algorithm that is provided in Natural is Logistic Regression, and this is the actual algorithm that we'll use to train our tweets sentiment. All right, so now that you have a trained model, it's time to see how well it performs. Unless you're super lucky or clairvoyant or something, you're probably going to need to tweak your model and retrain it until you reach some level of goodness. For the task of classification, these are some of the commonly used metrics, such as classifier accuracy, precision, and recall, which are information retrieval specific measures, as well as F measures, which are just a combination of precision and recall to give you an overall picture. As a recap of our classifier, We have logistic regression. We have some simple bag-of-word unigram features with some special normalization. We have our data set consisting of about 1.6 million tweets, and I segmented that to 90% randomly being used for training, and then about 10% or 160,000 tweets remaining to do the evaluation. And so how does this kind of model do? So throwing this simple model out, got an overall classification accuracy about 80%, which honestly is pretty good for something this simple and data that was more or less automatically retrieved. Depending on your task, you might want to get higher accuracy or have more variation. So I'll leave the evaluation phase to you, honestly. But to make use of your classifier, after you get some desired result, you're probably going to want to put in production. So the general steps around this involve saving or exporting the classifier in some representation, creating an application or integrating it into an existing application, loading this model, and then classifying new or unseen data. So moving forward with our logistic regression example, with natural, after you train by sending through all these tweets, you can call a save method, which will save the parameters relevant to your algorithm in a JSON file. And later on, when you're ready to do predictions, you can load this up again without retraining all over, and then make predictions on new tweets that come through. All right, so a couple notes on deploying an algorithm like this. So depending on what your domain or application is, you might be very sensitive to false positives or false negatives in the classification. So common ways people get around this is depending on how sensitive you are, you may want to specify a confidence threshold at which you'll fall back to the safer value if you're not certain, or you might even put a human in the loop to intervene in cases where you're really not certain. Another consideration is that not all of these models perform the same. Right? Some require a lot of memory, some are slow in inference or training, and as part of your evaluation process, you should definitely consider profiling the system as part of the criteria for selecting your algorithm or model. And another thing that I oftentimes see people forget is that the real world changes, and you want to adapt to that, right? Over time, new products will come out, new songs will come out, people say things differently or use different words. So you want to complete this feedback loop and retrain often or regularly, depending on your domain. So, now that we have the basics, mechanics of machine learning and an overview of how it works end to end, let's see what we can use our tools on. I did a literature search to see some examples of what people did in machine learning and JavaScript, and I think this is the best example I could find. Cat face detection, a very important problem, right? So this person, Heather, wrote a whole repo and application for finding cat faces in pictures. Essentially, what she does is cut up an image into different sub-windows and ask the question, is there a cat in this sub-image? And if so, there's a cat there, and we draw a bounding box around the different sub-images. She makes use of the histogram of oriented gradients, which is, or HOG descriptors, which is a fairly well-known feature in computer vision and image processing. And there's a lot of libraries that implement this for you if you're curious. And then she threw it at neural networks and SVMs. And this turned out to work fairly well, at least for cat images where the cat's face was head on or close to head on. And with respect to data, there's a lot of cat data out there, a lot, too much. If you're interested in cat data, here's one database of cat images. There's 10,000 cat images, of cat faces, 2 gigabytes of cat faces for all your cat face needs. And, it's like the output of some computer vision project. Like, it's kind of crazy what's out there. All right, and lastly, I'll quickly go over some other resources you might be interested in for folks that want to play around in machine learning, because it's not that scary, and there's a lot of resources out there to help you. So first off, where do I find data, right? Well, there's a lot of data out there, but unfortunately there isn't a single place to go find this data. If your application has information, that seems to be the most relevant place to get in your data. Otherwise, there are different public data sets, like Amazon Web Services has a public data set portal. Socrata could also be used if you're interested in open government data for part of your application. There's a well-known machine learning repository, dataset repository hosted by UC Irvine. There's even a subreddit dedicated to asking for data sets and sharing data sets. So a lot of stuff out there. Additionally, hosting your own end-to-end machine learning pipeline can be time-consuming and resource-intensive. So if this is something that's not your thing, you could kick it off to one of many different cloud or hosted machine learning solutions. Amazon and Microsoft both have pipelines for this, and there are many different third-party libraries Datto or BigML or Prediction.io. Here I note a few different NPM libraries that I found around different machine learning tasks. I would say that these all have different maturity levels, so I would pay attention to how well they perform for your specific task. And lastly, these are some of my favorite APIs around intelligent tasks. So Alchemy API is a great full suite of professional grade NLP AI suites. They have things for sentiment or entity extraction or other things related to natural language. I think they also do face detection and things like that. EchoNest is probably my favorite API of all time. It's used for music intelligence and music discovery. And then Wit AI is a helpful API I've seen that people use for entity extraction or intent detection in text and speech. Anyways, I'll post these slides and the links on Twitter later. But yeah, thanks for listening, and hope you learned a little bit.